All right, hello everyone. It is now October the 22nd, 2024. And my name is Rick Florence, and this is the Salon of Spirit. And I'm happy to see all y'all. And so today, what we're going to talk about, or what I'm going to talk about, I always say what we're, and I'm used to talking to people rather than a camera. So anyway, we're going to talk about cryptos. Cryptographic money is what they're calling it. Although I don't know that it's money. I guess we can use it as money, but it's Bitcoin, Litecoin, Ethereum, XRP, all this other ones. So what I wanted to do is kind of explain a little bit how it works. Not so much, whether you should buy it or not, or which ones to buy, anything like that. But I do want to talk to you a little bit about it. Now, cryptos is basically a computer-based accounting system, if you will. That's kind of what we have anyway. Federal Reserve notes are nothing more than just record entries in a computer or pieces of paper that they print, basically receipts representing that you have some number of credits with the system, I guess. But they're really, we've already went over this, so you guys know my opinion. You know what it is, so we're not going to go there. But the bottom line is, whenever you use the Federal Reserve money, paper money, and you use a like a credit card or debit card or anything like that, it's going to use encryption to get the make transactions between the point of sale, a little device there, and the bank. So cryptos is not really much different than that. They're just updating a ledger. But the difference is that one of the big differences is that the Federal Reserve money system is all in one bank, one big bank, Federal Reserve, and they are all members of the Federal Reserve. So it handles all the transactions. And so, whereas cryptos, for the most part, now it's possible to make what is called a crypto, or crypto is short for cryptography. It's possible to do a centralized system as well. And that's what they want to do with the new Fed money system and everything. They want to control it so that they get to create how many there are, and they can control the quantity and where it goes and who has it and watch everything. And obviously that's the game. Because they know you would think, well, why are they doing that? They already got a system and they got it all locked down, and they're making 2 or 3% off of every freaking transaction that happens. They're making a killing. So why is that? Why would they want to introduce a new, different system that is making buku tons of money, gives them lots of power? Well, that's because it's falling apart. Remember I talked to you about Ponzi scheme. You can't fix a Ponzi scheme. It's a Ponzi scheme. So they want to start over and have a new Ponzi scheme. I'm sure that's what they want to do. Now, that's all my opinion. So let's talk for a minute about why cryptos all of a sudden came on and was a big deal. The main thing that the crypto system does, it has a thing called a blockchain. And cryptos is just kind of a general marketing term. It has no technical specifications. There's some presumptions and assumptions that's made when you use that term. But it kind of, people figure that it was, it operated and worked on blockchain technology. So what's a blockchain? Well, it's a mechanism where a whole bunch of computers all make journal entries on it. And it's actually all these machines out there that are using that have got a copy of the blockchain itself. Basically, it's a data file, a big, huge data file. And that's what they all have a copy of. Since you put one thing on it after the other, they call it a blockchain. So if somebody makes a transaction, it goes on. The next one goes on, the next one after that. It keeps doing it. Now, but what's the big magic? Well, the big magic was that it solved the double spend problem. So they've been trying to do this for a long time. Having a more resilient, better system. A lot of people have talked about this. And Bitcoin came along and solved the algorithm, solved the double spend problem. So what is a double spend problem? A double spend problem is where somebody uses their number to buy something and then they do it somewhere else immediately thereafter to another place. And then the system allows them to spend their cryptos twice. So they had to fix that and figure out how to deal with it. And that's what they did, and that was the big magic. And the other thing is the people who are building the cryptos, the Bitcoin in particular, were trying to create a situation where there was a limited amount of money, so the banks couldn't keep on printing money out of thin air and keep creating more and more and making all of us debt slaves. So that was a big deal. So one of the problems that we have is updating the blockchain. Well, the blockchain is going to be on all these separate computers. Then how do you make sure that it all stays in sync? And how do you make sure that the transactions are completed and not get overwritten and that sort of thing? Because the way things used to work, or way things work with like, for example, spreadsheets. If you have done anything to do with computers using spreadsheets or word processing documents on a network, whereas you edit or try to edit and change or open another spreadsheet that's the same one somebody else is trying to open or has tried to open, or you have open in another window, it'll tell you, oh, well, somebody's already got it open. So when you're talking about a network, you have nodes on the network. So you have clients and you have server. Now this is where the big database of files sit. All the files are here. And this might be your spreadsheet is sitting out here on this thing. Let's say this is my.xls. So my.xls. And this client over here is running, little spreadsheet program. Well, it's A, B, C, D, E, 1, 2, 3, etc. And so you're running the spreadsheet and you open it over here. So you open, let's say your drive. Now sometimes it's transparent, especially when you start to talk about Google Drive. You don't even know this is going on and you don't have much control. I'm not a fan of Google Drive at all. I like the convenience of it. I like the easiness and all that, but it belies privacy and control, because Google has your files, all of them, on their server, and you don't even know where they are. And if there's some problem with their big system, like did actually happen with, what was it? Who was it that it happened to? It just happened. Oh, Microsoft. Office 365 went down. Well, when that goes down, everybody can't do their business anymore. Why are all the IT people jumped on this thing? They didn't want to at first. But like everything else, like how can we have Windows instead of OS2? Because the promoters of the functionality went around the IT people and went straight to the management of the company and convinced them how cheap it was going to be if they put everything up on their cloud. And so the IT people eventually just had no choice, and that's what they ended up doing. Now, the risk is that if you can't access that system, you can't do any business, period. And when you have your own server and network and everything, that you control it, then you might have a link down or something, but it doesn't stop internal users. The only way the internal system will stop working is if the servers themselves that are running your system die or have a problem. I mean, everybody has backups and redundancy and all that, so it doesn't die much. It's pretty rare if it ever does. But at least you have some control. The bosses of the company can say, hey, get your IT button, get that shit fixed. And then if they don't do it and don't get it done, they can always fire them and hire a new team. But you can't just fire Microsoft and hire a new team. That's not going to happen when you got everything on Office 365. So anyway, that's a digression. So let's come back over here. So we have a client PC out here. This is just a PC. And it's running client. It's a client in the connection. And here's a server sitting out there. Now everybody thinks that, a server is a specific kind of machine. But it's not really. The architecture of client and server architecture is a model or a design. And a device that's called the client is the requester. It requests. He requests service from a server. It's going to serve it. So this is a respondent. So when this computer, this software program says, hey, I want something from you, and he says, okay, here, I'm responding. This is the server, and that's the client. You can actually have two, what we call client machines, like two Windows machines, and you can connect to each other and share files back and forth. And who is the client, who is the server, all depends on who's responding. So the request goes this way, and that makes him the client, and the response goes that way, and that makes him the server. Now, they have hardware devices called servers. Basically, they're just PCs, same kind of processors. There might be more advanced stuff, a bigger, more powerful processor than your laptop is, but it's still Intel architecture. It's still running 64-bit Windows-based type technology. They've made the server more multicasting. They take out some things that you don't need, that you may need over here, like graphics capabilities and stuff like that. You might have less functionality for that here, but you got a lot more power, more processors, more memory in better quality drives and all that in this machine. But although you can put Windows on it more likely, and you can just run it as a client if you want. And it will actually be client to some other devices. There could be another server, and he talks to that one. And when he does, it's now the server, the client, and that's the other one, the server. So, but here's the thing. If you have another PC over here, and that PC over there is a client also. So you got two of them. So he's a client. Change this around. And he's got the spreadsheet too. All right. A, B, C, etc. And there's a spreadsheet on here. And then you're trying to access this spreadsheet, and it's got a mapping to the server. And you guys have a lot of people who've been using computers for a long time. You have local servers. You've got drive letters out there, and you open your files. They're on the drive number. So we're going to call this guy server 1. And then we're going to have a share that's pointing to this where this file is. Because if you look in your computer, you got C:\\, D:\\, E, etc. And those are representing places on the hard drive of this server. And you also have the same thing. You've got C:\\, over here. You might have a CD-ROM or another drive, etc. Same thing. C, D. And when you plug in a USB drive, well, the operating system goes out and says, well, what's my next available drive letter? And it slaps that on there. So that might be the USB drive. But in the networking world, they'll have another one, like let's call it S for shared drive or server drive. And that points to a place over here. So this guy will have, maybe it has a G drive, a physical drive that's on this machine called, and it's G:. And it has a little name called, shared space. And that is pointing to a place on this drive. So that when you go and you map the drive, you map S to this server 1 shared, which you may have actually seen that before. Make that a 1. And this person over here looks in their little Windows browser thing, or in Apple does the same thing. Go on the chooser and look. But you can see that it says, oh, this S drive is connected to or pointing at this thing right here. And so from your perspective, it looks like S:/. From this server's perspective, it might be G:/shared. And then there's a file in there like my.xls. So what's happening is that this client, and this also has an S drive over here, and everybody just calls it by letter most of the time. And so this computer over here says, well, I got the connection to the same place, right? The same exact spot. And we have this little machine out here, spreadsheet sheet, and that's my XLS file. And the thing is when he opens that file and wants to get to it, well, it says, okay, you can have that file. I'm going to give you a copy. I'm going to open it. I'm going to lock the file. That means when he tries to open it, that file's locked. But it says you want a copy. Now, what used to happen in the early days, before they really had the file sharing thing worked out that good, and it were happening on databases and things, you need to open the file and lock it if you're going to read and write to it. If you're just going to read it, you can open it read only. Now, the problem is if you did that, if he opened the file, and you opened it read only, and he wrote open it read write, then when this PC made a change, or the user made a change to the spreadsheet and saved it, then this guy's copy that's got in his computer is out of date. But he'd have to go get another copy to get the data that he just wrote on the file. Now I'm going through all this a little bit, and hopefully it's not difficult to understand, but because it's kind of reflects directly on what's happening with the crypto system and the double spend problem. And how do you keep from spending the stuff more than one and make sure everybody has a copy? So that's the big problem right there. So if this client here opens this file, read write, then what happens, this operating system will tell the PC, hey, you're getting a read copy, and you can't save that read copy back here. And so then he can sit there and have it locked and do what he wants. In the meantime, nobody else can touch this file. So then when he saves this copy, let's say somebody else were to have opened that copy a minute later and make a change and save it, then he doesn't know that the file's changed. He's got a different one. He has to go read and get another copy of it. Well, the software doesn't really know how this is going on. It just knows I'm trying to open the file. The file let me open it. The server let me open the file, read write. I've got exclusive access to it, and I go for lunch. Now nobody else can make any changes to the file. So this is like multi-file access problem that is always out there in the networking and PC world. Now, so cryptos. Well, cryptos have the same thing. They have the servers and they have clients, but we call them a different thing because they love to change the name. They're trying to make everybody think they, give them some point of reference that they can use in their brain. So even though they don't understand really what's going on, they're going to call this thing a miner. Miner. Miner equals server. And this is a little different. Client is just the solver. This is the wallet software. Okay? The wallet software. And the wallet is just a file that keeps access to the crypto that's out on the blockchain. So I'm going to erase this a minute because it's getting busy. Let's see how much time I got left to get this done because I don't want to spend a whole lot of time. I've got some other things to do. Let's see. There we go. All right. So then you have your PC or your cell phone or your, tablet or whatever. Doesn't matter. And on here you've got wallet software. Now, everybody thinks, oh, well, I've got my stuff in my wallet. Well, you don't have anything in your wallet except for keys. It'd be like saying you have a little key. They used to make them. They don't see people doing them anymore. I hang mine on this daggum crazy, got a bunch of keys here for all kinds of little boxes and other kinds of crap I had. I need to go by and get rid of some of those because they're not good anymore. But anyway, you've got the wallet software that's on here. Now you've got the miners. The miners are out here. The servers, remember those are the miners. And the miners have got a copy of the blockchain. And that's where your cryptos are. And there's a whole bunch of them. And they're spread out all over the world. And they all talk to each other. And in order to keep this blockchain, so everything's in sync, so when you make a change, nobody else can spend it. Now I'm going to tell you how all that works. But the bottom line is that these miners keep it all in sync. Make sure that everything's good. That's why sometimes if you have used cryptos, you'll find it says, well, we're waiting for so many confirmations before we're going to give you the cryptos out of our wallet or release them for you to use it. And what that means is like you have maybe 1,000 miners out there, or it can be even more of them. And these guys are processing the transactions, and they are earning more crypto from the blockchain, depending on the blockchain mechanism, the type that's used. And there's a proof of work. They have different kinds too, like proof of work and proof of what's it called? I'll remember in a minute. But bottom line is it's stake. or you stake them. So what you do is you lock up some of your cryptos in the system, and then it won't let you take them out again. It holds them in there, and you earn a little interest on it. And the miners get paid from the fees that are charged when the wallet software tries to make a change on the blockchain. So this guy, the wallet software has little files on there, has some data on there called keys. Okay? And some people call them wallet words, and some they call them all kinds of things. But the bottom line is they got keys. And the way it works is the wallet software and this system is a public-private key cryptography system. Oh, that's a big fat word, isn't it? Well, all it means is that if you want to do a transaction, you use your key. We say it's the private key. And you have a public key. And the public key, you give it to people. The private key, you never give it to anybody. Because whoever has the private key has the control. And when this software wants to make a change on the blockchain, the miners have to say, yeah, you got access to this. And so what happens is the private key is used to encrypt the transaction and sent to the miners and the blockchain is changed. Only those who have the private key can make a change to the blockchain. Well, they basically telling the miner, here, you make the change. And here's the change I want you to make. And now that chain is that one's out there. Now the deal is that you're basically sending, making a change on the public key of the other person. So you can decrypt the transaction with the public key, but you can't encrypt a new transaction with the public key. So everybody knows the public key, so they can look on the blockchain and see everything and all that, but nobody can make a change to it unless they have the private key. So what your wallet does, the wallet software does two things. It interacts with the network, and it stores and secures your private keys. That's those words. If you try to go get a wallet, and they have wallet words and all that, and they have a standard for using the wallet words to create a bunch of private addresses. And so that's it. The bottom line is, despite all the stuff that everybody's talking about, how, you can have this and I've got, or do you have any cryptos? No, you don't. The cryptos are on the blockchain. And the blockchain is international all over the planet. Now, that one brings up an interesting question of jurisdiction, doesn't it? Jurisdiction over the thing. There's several different kinds of jurisdiction. I just lost my marker. So I'm going to have to come back to this in a second. Oh. Okay, that was right there. I could have reached down there and grabbed it. All right, so the funny thing is that how do you deal with, when you're talking about law, you've got the jurisdiction over the place, and you have jurisdiction over the subject matter, and you have jurisdiction over the person. Those are the three things that are kinds of jurisdiction. In personam, they won't go into the fancy names, but the bottom line is, does the court have jurisdiction over you? Does it have jurisdiction over where the event occurred? And does it have it over the subject? So if the law has been passed about something in a jurisdiction like city or county or state or federal, then does that court have jurisdiction over that issue? So, like the Supreme Court just basically told everybody that the United States federal government doesn't have jurisdiction over abortion. That's a state matter. So that's why it's all back in the states. Not because they didn't want to have it or whatever. They didn't issue a rule on that. They just said, hey, we shouldn't have ever had this in the first place because we've never been given jurisdiction over this. And so they didn't have subject matter jurisdiction. That's why they reversed themselves. So, okay, anyway, so the blockchain is where the cryptos are. There's no cryptos here. You have no cryptos in your wallet. You have no cryptos in your possession. Now, you have the ability to get it. It's kind of like having the keys. Well, just because you got the key to the house doesn't mean you have the house. If you have your keys to your apartment complex and they lock the building, but you still have your key that works, doesn't mean you're in the house or you're in there that you can sell the apartment just because you got keys. So, it's a key holder. And every different crypto has a different set of keys. So if you got Bitcoin, you got Bitcoin Cash, you got Litecoin, you got Ethereum, whatever. They all have different sets of keys, and the software keeps it all figured out. So it knows, okay, here's the keys for this one, and here's the keys for this one, and here's the keys. So when you spend it, it grabs a key from its little file on your phone or your computer, or whatever, and it encrypts the transactions and sends them on its way. So they can decrypt it with the public key. And you send it to the public key. That's another thing. They use the two addresses, the public key, the other guy's public key. So your public key is available, and they can decrypt your transactions with the public key, but they cannot re-encrypt. That means they can't create a new transaction from your address, which is your private address. Well, it uses your public address too. To say, oh, I'm sending it to that guy. But you still have to have this key before you can encrypt and change the transaction. And that's the way the thing works. And isn't that difficult? But it just makes those changes. And all these miners are keeping track of everything. And they make sure that all the updates are happening properly. And sometimes the manufacturer, the trading platforms and stuff say, hey, you can't encrypt that. You can't spend the money until there's 8 of them. So 8 or 10 or 12 or 15 or 16. There's some number. Depends on, then to make sure that enough of these miners out here say, yay, verily, that's a good thing, or enough time has passed and the blockchains continue to be changed so that you can't insert another transaction in the middle of the blockchain. If they did that, the miner's copy would be ignored, and then another miner would take care of it. And they send out a broadcast to the miners and tell them, hey, here's a transaction. So that right there, folks, is how the thing works. In a nutshell. Now, there's a whole lot of other topics and other things that we could talk about, but the purpose of this video is to give you a little information about how does this crypto stuff work and what's it all about. And since your cell phone has enough computing power, you can interact with the blockchain right there. And a lot of people, I want to tell you one more thing about this, and that's, let's see how much time. Yep, I still got time. And that is, everybody says, oh, they hacked Bitcoin, they hacked this, they can't. It's not possible to hack Bitcoin. Because the different coins is not the miner. It's not the wallet. The data that's on the blockchain is what is not, it's not executable. It doesn't run, it doesn't execute. It's like if you put a 5 in a spreadsheet, the 5 is a 5. There's no way to, how do you hack that? You can't hack it. What does hack it mean? Hack it means I'm breaking in through a password, some mechanism to break into your computer. And most of the time, hacks are not hacks at all. Most of the time, they're compromised passwords. Somebody's password was on their computer in a text file, and they stole it, or they did a keylogger thing, and they're monitoring your computer, and they saw that you typed your key in, and then that's how they get in. And then they say, oh, you hacked in. Like you're some genius IT dude. No, you're a thief. He put a program on that he got off of the website somewhere. I like to say dark web. I'm like, yeah, okay, that's right. That's ridiculous. But nevertheless, they get it out there off of a network, off of a server, somehow or another, whether they stole it and broke into, like, for example, a bank. If they got hacked, and they call it hacked. But if they got through the security system, because there's a vulnerability that they know about, and they were able to access files that are on that little database thing I drew down here, a little circle thing with it looks like a drum, like that. And we put the files. That's a symbol we'll use for building network diagrams. And we got in here and got this and copied it. There was an event that happened a few years ago. I don't say it might have been WikiLeaks thing. But they were trying to say that, I think it was WikiLeaks, and they supposedly gave a copy of this big database to somebody overseas. And the database was so big, and then the internet was so slow compared to what it is today, that it would have taken them months or years to copy that much data to get it to the other side of the world. But everybody and their dog, it doesn't know a dang thing about computers and networking, all said, oh my goodness, they stole it. Well, it's not possible for them to steal it because it would take too long. When you get internet bandwidth at your house, you have 2 numbers. Nobody ever pays attention to that. They always say, oh yeah, I got 100 meg, I got 300 meg, I got 400 meg, I got a gigabit. Yeah, but there's 2 numbers. You see, when they say it's 400 meg, And that's bits, by the way, not bytes. 400 meg, they leave off the other part. The other part is 20 meg. And what this is download. And this is basically receive, and this is send. And I say download, but that's because of the term they use. A lot of people use, but the real action, this is receive. And that's send. So if we have the client, and he sends a request to the server, that is send. From these circuits, they sell you a 20/400, which is 20 down, 400 up. I mean, the other way around, 20 up and 400 down. So that means that you can only send 20 megabits, but you can pull it down off the internet when you're browsing websites. And then that makes some sense. But it's kind of interesting that the computers don't really care which way it is. It's an artificial limit. And a lot of reasons they do that is they don't want you hosting websites on your private thing at home. At least not anything other than just what friends and a couple of friends might want to use it. They don't want you to do that, so they limit that other side. And then a lot of the circuits out there are asynchronous. When you send a request, it goes out and then it comes back, the answer. But the full synchronous circuits, you send and receive simultaneously. So another system might be saying, download me a file. At the same time, you go send a request, and it'll keep going and won't slow down the download. But the way most of these systems are, a few packets, the network system will say, oh, he needs to go out, so it stops the download. You don't know, it's just so fast. But he sends it out to get the request out there, and then he keeps on sending the data down too. So anyway, 2040, really that's why it's different. So just thought you might want to know about that. There's a lot of this computer crap that people don't know. And maybe it'll help you understand a little bit more about cryptos and what they all are. And then there's a lot of issues about different kinds of cryptos. What's the purpose of them? Bitcoin, everybody calls them money, but Bitcoin is designed for that primarily. But they can do a lot of other things. They got things like smart contracts and a whole lot of different functionality. And some of these cryptos, these projects, if you will, they're using blockchain technology to implement a solution to the problem. One of them is awesome. It's Theta. And Theta has the ability to do a lot of things. And one of the big things when I first saw it that I liked is the ability to use part of your hard drive to store bits of videos and stuff, and basically take on YouTube and be able to, you want to watch a movie? Well, the system will go out there and pull parts of the movie off of a whole bunch of people's different computers, reassemble that in a stream and send it to you. Instead of everybody having to go back to the core network. But we'll talk about some more computer stuff in the future. And just so you know, I've been doing this a long time. I wrote my first program in 1975 when I was in high school. And I went through high school. I was in computer class I think I took 2 or 3 classes in computers at the time. It was really, really new. It was actually in the math class. I call it an advanced math, which I was not that great at math. But anyway, so I did that, and then I went to Texas Tech, and I got my MIS degree. I spent some time while I was pretty good at it. I like doing computer stuff, and ended up teaching. I think I was a sophomore, maybe a junior, and I was tutoring the Texas Tech women's volleyball team and how to write Fortran programs. So then I went off and did a career. I had an MIS degree and a management degree, and so I went off and started working for mainframe stuff. And then the PCs came out, and of course I was young back then. So boy, the hot rod kids get out there and start playing with PCs and networks and that kind of stuff. And I built the first, as far as I'm aware, I'm pretty sure I was the IS&S department at TI, and I built the first production, what they call production application that ran on a local area network. We were taking an old software program off of a mini computer system, which mini computers they weren't little, they were big. They were like room-sized machines, but they weren't the mainframes. They were a step down from the mainframes. And we ported that application down to a local area network with a few, client PCs. So anyway, that's what I did. And I've spent a lot of years in all kinds of stuff, computers, technology, primarily, somehow network related, in almost ever since networks came out, local area networks, that is, and then wide area networks, which is just we could talk about what the web internet is and all that, but we'll do that another time. So you guys will appreciate it. I would have really appreciated it if you'd forward this to anybody else or any of my other videos I'm putting up, and see if I can get some people to say they like this. So if they do, it tells me to keep doing it. If people don't like it, then there's not a lot of point to keep doing it, but I'll do it for a while yet. We'll see how things go. I like to teach, and so hopefully you're understanding what I'm saying, and I'm not talking too fast, because I know when I start talking about this stuff, it comes out pretty quick. So I have no problem with you putting a question out there, and I'll answer your question. And if it's more of a detailed question and it seems like people might want to know, or I didn't do a good enough job speaking, then I will, do another video and update it. It doesn't take long to do this. So anyway, y'all have a great day, and I'll see you the next time. Please like, subscribe, and forward the videos to your friends and family and anybody else you want to. Thanks. Bye-bye.